Welcome to Behind the Curtain Wall, the series where we take a deep dive into the world of building envelopes, the technology behind modern facades, the standards that govern them, and how buildings actually perform once they are standing. This is a special episode. Joining us from Venice, Italy, is Doctor Angela Mejorin, founder and curator of Performance-Based Facade Design, the conference that brings the facade world to Venice every September. An engineer by training and a building envelope consultant, Angela also sits on ISO and ASTM standards committees as a project leader and voting member. She built the conference around a simple observation. The people who design facades, supply them, research them, and write the standards for them almost never end up in the same room. So, she made a room. As always, she is in conversation with our founder and principal at Miami Curtain Wall, John Medina, who will be presenting in Venice this September. What follows moves from facade serviceability standards at ASTM to wind-borne debris and impact testing, to curved glass, and why it remains one of the hardest things in the industry to get right. And it keeps returning to one question. How do you read an existing facade, and what does the evidence support before anyone decides to replace it? This is 21 Ways to Read a Facade, Serviceability, Standards, and the 2026 PBFD Conference. Let's listen in.
Thank you very much. Thank you very much for the invitation. It's a great pleasure to be part of this project you have.
Absolutely. Angela, give us a little bit of background of how you got started and what the conference is about.
Okay, I'm an engineer as a background, and currently I work as a building envelope consultant, and I sit in different standardization bodies. I sit in ISO and ASTM, where I'm currently project leader and also voting member. And I started this conference project. The conference name is Performance-Based Facade Design. So the focus is the building enclosure performance. I started it 4 years ago now because most of the people that are involved in the facade development, they never sit in the same room. I'm talking about people designing the facade, people consulting on different aspects, the suppliers, but also the research bodies and the standardization authorities. And the conference is where all these people sit together once a year in Venice.
Excellent. And tell me a little bit about what can we expect this year in terms of speakers, in terms of topics. What are you most looking forward to hearing about?
So every year we have different themes. This year we focus on durability for the seminar. The second day we focus on facade serviceability, failures and lessons learned. And we'll hear also from John's about his experience. The conference runs for 3 days, so it's September 16 to the 18 this year, and the last day is usually for offsite activities linked to architecture and different technical content. This year is the most exciting conference lineup so far. We have keynotes from Kengo Kuma and Associates, Populous Architects, UNS, ETH Zurich for the real estate department, and Covivio. They are developers in Europe in between France and Italy. So, and besides that, we have 30 plus speakers. And the first Performance-Based Facade Design career recognition will give to Massimo Colomban, who founded the Per Massilisa group back in time.
And John, I know you have history with the Per Massilisa. Can you talk a little bit about that?
Yeah, I had the opportunity to meet him. I would say roughly, 1998, 1997, where we introduced Per Massilisa to the American market with a building on Brickell Avenue called Espiritu Santo, which is now Brickell Arch, and it was a wonderful product. It really showed an enormous amount of technical skill, where glass deletion of specific lights that were curved, and all sorts of geometries that were very difficult to build. No one was doing that kind of work in the United States that we could count on for the project, and we were able to be part of that from the onset with KPF was the architects, and we were able to sort of do the project twice. The first time when it was completed, I think because it was a flagship, the pricing was very, very reasonable at about $23 million to build this 34-story envelope. The following year, 2 years later, there was a hurricane, and we got to build it again. And that time it cost $47 million.
Wow.
Lost 17,000. Well, the glass did not break. The glass broke, but it wasn't blown out, and it served its purpose. So we were able to keep the building operational while we did the work. It took 2.5 years to do the work and complete the work. 7 lines of insurance had to pay in the $47 million. But the building remained. The bank continued to operate. It was a federal bank and had to be opened within 48 hours. And in that time we got to know Venice very well. The plant was just outside of Venice.
Now, I want to take a bit of a turn here and talk a bit about standards. Angela, I know you have a lot of interest in standards like ASTM and the international standards development. Talk to me about how you got involved in that and where is that today. And I think the conference is involved with, I think there's a committee involved with the conference, correct?
That's correct. So I got involved with standard development at the end of 2019, but with ISO. It was my way to work in the academic environment and somehow be linked to the real world. So all the stuff I was researching and implementing could have had an outcome useful for our colleagues. And there was project leader for this standard for windburn debris resistance of facades, and was also the focus of my PhD project. Nowadays, I'm much more involved with ASTM. This because I moved to North America 5 years ago, and for a limited period of time, and I started working and contributing to standards development there. So currently, PBFD has a link with ASTM under an editorial partnership that will be running for 2 years. So all the workshop participants of the PBFD workshop this year, they are implementing a technical paper that is going to be published and presented in 2027 at the conference. So this is a way for technical content to be also presented out of the ASTM committee weeks, because that's the usual type of setup that these workshops have in an international venue in Venice, Italy, and with the focus on facades. There is a person I'd like to mention, that is Dan Lemieux, who is the chair of the ASTM EO6 Performance of Buildings group. And also somehow very much involved with the EO655 that is for building enclosures. So the partnership is linked to the building enclosure subcommittee.
That's interesting. So I want to take an opportunity to kind of rewind time a little bit here with that same committee, because I know John was involved in the committee many years ago John, can you talk a little bit about your involvement with Committee EO6?
So it's interesting that as I get to know you, Angela, we have kind of like a shared motive. When it seems like when you started, you started looking at performance ratings and things of that nature at kind of an academic level, and I had back in I'd say 81 through 83, worked at a testing laboratory called Construction Research Laboratory in Medley, Florida, that had been developed by a professor named A. Saknowski, named Sack. His nickname was Sack. And back in 59, he started developing test procedures for water infiltration and structural and so forth. Kind of one of the two or three innovators in the country at the time. One was Jack Stevens out of New York. There's another plant in New Jersey that were like laboratories that were just getting off. And SAC was probably the most pernicious or the most recognized. And I had worked there a couple of years. I really took an interest in the skin. As an architect, I eat through my eyes. I like to see things and see things that last a long time. And I worked there for 2 years, and I was just enthralled. And when I went off to my master's in architecture school, kind of like you with your PhD program, when you were, I wrote my thesis on the performance ratings of curtain wall glazing systems, based on my experience at the laboratory. And that was and there was a calling right at the same time when I was leaving, that I was leaving the laboratory and starting at the University of Florida for an examination of performance ratings by this same chapter, ASTM 06, the subcommittee on performance ratings, sustainability, all of the maintenance, all these sort of things, and my thesis is precisely on that. No, and so kind of like at an academic level, I think that was the start. The calling was in '84. I wrote my thesis in '86, and I've evolved my thesis based on ASTM. It was presented to the subcommittee back at that time, which was 06.55, and I've sort of modified that, which I had developed from an academic level, into a real tool, which is what I'm going to be talking about at the conference with Angela.
Interesting. And Angela, talk to me a little bit about the importance of why international practice matters in terms of the conference, bringing in so many. You have a lot of big players coming, right, from all over the world. Tell me, what's the real importance of bringing in all these different minds from different backgrounds?
So I find it very valuable, and that's something also attendees always like, to have this really a full international conversation, because sometimes certain issues and challenges that maybe have been addressed in a certain way, in a successful way, somewhere in the world, they can find an applicability also somewhere else, under different circumstances, under different also standardization requirements. And that's the strength of performance-based facade design, I believe, because addressing certain topics every year with different perspectives, with different backgrounds. Attendees, they come from for different continents. There is a big participation this year from the United States, from Canada. There are representatives from all over Europe, attendees, confirmed attendees from Japan, from the Middle East. So it's a very international crowd, and often in times there are venues that claim the international appeal, but eventually it's a very regional type of conversation.
Sure. John, I see you flipping through your thesis.
Yeah.
Going back to what you'd be presenting at the conference, can you talk a little bit about the framework that you mentioned, the Turning 21, and what you'd be presenting a little bit at the conference?
Yeah, so I think that it's sort of and I think Angela has standards that she's been working on that are very strong standards that work within the framework of a methodology, that I've created over the past 40 plus years, and I think that I started off with we do a great deal of consulting on tall buildings, curtain walls, window walls, and so forth, and I started off with what does a designer need to select, for suitability reasons, a glazing assembly. That was generally, I think, the anticipated direction I took, and through the years, I've found myself in the position to judge the suitability, the maintenance, the performance over work that I've either installed or somehow been involved in installation, or that have been affected through injuries from either storms or installation. No, and so I what we here at Miami Curtain Wall developed was a methodology that has sort of been standardized, which is called Turning 21, which is based off of the same first 21 items that back in 1984 we were looking at as designers. Now, from the standpoint of forensics, we have implemented that to deal with large data sets being many hundreds or many thousands of items that have to do with glazing, no? And we've looked at these items from a very forensic standpoint, which is the standard ASTM E2128, ASTM E1105. From more of a forensic standpoint, those standards that all play a part in creating a snapshot of what may be happening many years later, maybe a year after a building is completed, or maybe 20 years after a building is completed. No, and so that's kind of been a culmination of work that we've done. I would say more so in the last 10 years, because of the work that we've been finding ourselves called to look at as experts, in the field of glazing.
Where does this best apply? Obviously, in Miami, it's hurricane season. I feel like it's almost year round. How does this framework best suit climates and conditions like here in South Florida?
So talking about just for context about this new standard that is under development right now at the ASTM level, it's about serviceability when testing of full-scale building enclosures and systems. So it's gonna be very helpful for building owners on top of it, because when it comes to issues related to wind-induced noise and vibration, these are issues the building owners have because of the performance of these envelopes, also for the noise pollution. So because noise pollution, it can be they can be cited by the environmental I can't remember the body now, but I mean, they can have issues with the municipality and so on. It's a cascade effect, and also with the building users. On top of it, this type of protocol can help and to check in a laboratory about openable elements, how these elements they behave under real wind gusts. And therefore, for contexts like Florida, for sure, it would be a very, very relevant tool that can be used from consultants for building enclosure commissioning and so on. So this type of context, so the hurricane-prone areas, for sure they'll be interested, but also other type of regions, because nowadays with climate change, I don't want to say something that it's very common to say, but our environment is changing everywhere in the world. We experience also in Italy a lot of tornadoes every year, and therefore these standards they can be applicable anywhere in the world.
And talking about performance in buildings and impact testing, you have a bit of experience in that, right, Angela? Could you talk a little bit about that?
Yeah, so what I've been focusing on for a few years, first working with the used to be called Council on Tall Buildings and Urban Habitat, now Council on Vertical Urbanism. I was focusing in the Asia Pacific region and their requirements for windborne debris resistance of facades. Of course, the Miami-Dade was my benchmark. And so I got passionate about this topic also with this changing environment we are experiencing. And I found out in ASTM standards something very intriguing, so that professionals, they could go for engineering assumptions to come up with alternative impact test requirements, considering different projectiles being used for the testing and different impact velocities based on engineering calculation. And so I started working in the wind engineering field to develop an alternative design framework for windborne debris resistance of facades. And this framework is also included in the ISO standard that was published at the end of 2024 that I mentioned before. So somehow I find it valuable because the 2x4, like the missile that is used to conduct these impact tests, it's representative of the balloon free construction, but many contexts they don't have this type of construction in the surrounding environment, but they have other urban objects that can fly and eventually hit a facade. We have had with John a long discussion about the importance of burn debris resistance of facades, because it has been accounted in many studies that since it's a cascade effect, when the building envelope breaks and the barrier is not existing anymore to protect the internal environment, basically the cost of reparation can raise consistently.
And let's bring it back to the conference. So do you think that your experience and your research, talk to me how that formed the idea of having this conference and bringing it all together?
So I like people, I think, because otherwise I wouldn't organize something to bring people together. And I also love the multidisciplinary conversation, and building enclosures, they are the most sophisticated element of our buildings. So I started my career working for general contractors. I'm very passionate about also going on site, etc. And it was occasion, sort of natural outcome to bring a lot of different interests together in the same room. Also, I found that most of the venues that are usually important for academic representatives, they were not the same ones of the industry leaders. And so what I'm trying to do is to put all these stakeholders in the same room. And so this year and the past year, I have having also the developers on board.
So I think you had mentioned, Angela, that the curved one is the flat iron project that I was a consultant on that, as well as I did the threshold inspections of that building when it was constructed in Florida. For the most part, signed off that the glazing, waterproofing, railing, and roofing was installed properly.
This is
Yeah,
the
yeah,
the curved
right.
window, the curved glazing. Talk to us a little bit about that. What are your thoughts, both of you, on this curved glazing?
Curved glass, and the design of curved glass is fairly entertaining when you think about the laminations of glass that are required to comply with impact in South Florida. Impact at many levels, uh, bomb blast proof, bulletproof, and then hurricane proof. Hurricane falls into category number 3 now. No, and then because of changes in weather, more and more you're seeing buildings that have that are insulated. So you have laminated insulated that has to meet those performance criteria. In addition to that, an architect's desire that you can see through the glass, and it doesn't seem to be something out of a carnival where the glass is distorted in a way that either makes you too skinny or too fat when you look through it, right? The reflection, and so a glass that's curved has all of those performance rating criteria assigned to it. It's more easily developed, but the problem is that there are not many places in the world that makes it, so that you have to now ship it. And in the delivery process, for every light you install, you may lose 1 or 2 lights, which becomes a very costly process. And I think that there's the at a very microscopic level, as you laminate glass into cavities that are sealed, oftentimes you have things that grow inside them that you don't expect, because the microclimate in South Florida allows for most organic things to grow, and sometimes they grow inside your glass, which is always sort of interesting, where you can see these blotches of green stuff that you didn't expect show up in curved glass. So kind of from, if you just looked at that as an isolated, not everybody does a curved glass because it's so expensive, but then the problems you discover in curved glass are oftentimes very complicated, exciting for us, for me and Angela, but for other people, not so exciting. When you find some kind of growy inside you think that you've covered everything, and the seal has somehow been sealed off, but something, some seed was left behind in the cavity, and there's enough oxygen there to allow this growth to occur, and you suddenly find a green blotch after you've built a 60-story building. So those are the things you look for as an expert, and usually you're called upon when some of these apartments in Florida can sell for 30, 40, $50 million. People don't like to see green blotches. At that point, at the very micro level,
You can't
it becomes
disagree for those.
it becomes very important, right? You don't think about the hurricane that you're protected against, or bomb blast, or bulletproof. So there's some things that you learn along the way that by watching the install. It takes a very talented group of people to actually install curved glass so that it doesn't suddenly break, and then manufacturers there's not that many outfits in the world that can make a light of glass at the the arc that you want it to be.
I find like curved glass very interesting also because it leaves the architects free to experiment and to create these incredible shapes. One of my favorite architects used to be Franco Gehry, who pushed the envelope to the next level with a lot of collaborations with Permastilisa, but besides that, with these incredible curves, and nowadays I should mention Zadid and other key players of the architecture world. But I find it was very interesting to be involved in this book chapter development with this case study, because the challenges of curved glass for the testing protocols for hurricane-prone regions, that was something different. And I agree there are not many companies that are capable of implementing such solutions. But nowadays we have this also good technologies when it comes to interlayer solutions that are like much more stable. Another challenge mentioned in this book chapter for the South Flagler House, that's the third residential project that is included, is for high performance thermal solutions with IGUs in hurricane prone regions. So high performance, high thermal performance, and also impact performances, and that was interesting too.
That the when you think about curved glass, 20, 30, 40 years ago, a light of glass was maybe 6 feet by with an arch, the circumference of maybe 4 or 5 feet. That was pretty much it. With the evolution of glass technology, bigger is always better, right? So now it's no longer 6 by 4; it's 12, 13 by 8 or 7 feet tall, right? Uh, 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 Glass seems to be certain and stable, but really glass isn't stable. It just appears to be stable. So what happens in when you have a lighted glass that is not square, and it is moved around to be installed, you can easily bow the glass in a direction that you could cause it to crack, or you could rack the glass in a way that you could cause it to crack. And the larger the light, or the aspect ratio, the greater the chances that you're going to have that to happen. So when we're talking about applicators or installers, you have a very talented group of people that do that, but the folks that make the glass and move the glass around in a plant, they're the folks that they measure 5 times and then cut once, right? Because it's such, glass is so fragile. People forget that glass is fragile because the technology is advanced so much that people call it, impact glass. Well, glass breaks, right? So when you take some of the super high rises that are about to start kind of coming into, in fact, they're already here in South Florida. We're working on a number of them. and you put a curved glass in there, they have to deal with the rotation or the rotation of the building. Okay, they have to deal with the translation between floors, where and then the racking, right? It normal lights of glass where where they were pretty much square. If that frame racks at all, the glass, you establish pressure points on the glass, and then suddenly the frame becomes a rhombus. The glass inside of it is held with gaskets or sealant. Now something impinged on the glass and it causes it to fail. So glass technology has evolved, especially because of all of the damages in the Houston area and in the Miami area from hurricanes. I think that you started off, Angela, talking about cascading. That's something that you don't hear a whole lot of people talk about. And the fact that, Angela, you're from Europe and you're talking about cascading. I've seen cascading. Cascading is what it means. It's like the glass literally is falling, breaking, because it's tempered glass into chars, the small BBs. And as they fall from like the 60th floor to the 50th floor to the 40th floor, it's more and more breakage, and the glass is popping and breaking. By the time you get to the bottom, the wind didn't affect the bottom floors, but on the way down, it's broken everything. Meanwhile, you also have debris from other buildings, like satellite dishes become frisbees; they hit the glass. You have stucco and concrete, ballast. Old buildings that have ballast that's no longer allowed. Ballast is pea gravel. All of that goes into the wind. It's wind swept. It becomes part of the cascade, right? And literally having seen it, it becomes kind of something that is it's a known entity when storms happen, and it shuts down entire sections of neighborhoods because the glass becomes unstable. It's unstable when you install it, but with a high degree of confidence that it's not going to break when you install it. But once the glass is injured, that glass is forever damaged and should be replaced. And sometimes you can't tell the injury, the impact, until maybe a year later that the building's gone through several cycles of wind and rain and ultraviolet and sun. So so now you add to that the level of complexity that Angela is talking about, a curved light of glass. And no longer is it curved in one direction. It could be curved where it's more of a cone that is smaller at the top and curved and wider at the bottom. And so the level of complexity has grown as technology and AI and computer design programs has evolved. You could do more stuff. And I think Frank Gehry is a perfect example of how he took the skin and made something very heavy look very, very light. Very shapeless. And I think that that's something very special about what Frank Gehry brought to architecture. The ability of making something almost seem cloth-like, when in reality it's very, very heavy. A light of glass could weigh 1,000 pounds. It could be a way. It'll crush you if it falls on you. Of course, it'll cut you, but if it falls on you. But if it a light of glass has the ability to crush you. So the glass technology has become a greater psychological barrier against the environment, against hurricanes, but at the same time, the larger the light, the greater chance of injury from all sorts of things, right? And so design, from a design standpoint, I think Angela talking about performance rating requirements, how to make these things where you can establish what the expected performance is. I think it's a great great outcome of a conference where everybody could be talking about the same things. Designers can be talking about that.
In terms of maintenance, how does that play a role in terms of the performance of the glazing systems? Is that something that should be incorporated from the beginning? Where does maintenance play in the role in a lot of these more exotic and larger lights of glass that are being installed now?
So for sure, now we all know that maintenance should be included in the conversation since the very early stage of the design. But I like to go beyond this type of view because sometimes we have projects where recladding strategies are undergone, right? And somehow it's because there are no possibilities to keep the existing cladding to go for performance that is in line with the current requirements. So I don't want to see those elements being demolished and maybe recycled just as it is, but I like to see them nowadays with all these AI tools that we have as elements that are very, very strong from an informative perspective. So those elements, they can be used as trackers for other envelopes in our building stock to also extrapolate data and therefore study and implement strategies to move forward in the most efficient way. You've mentioned before AI and how things are being implemented in a very, very fast environment in the last years, and I see it as an important type of information to look also at the buildings and the envelopes that have been demolished in the last years, because somehow we take them down, but we don't look in a very detailed way at the value they can bring to our projects. I would say.
Yeah. I think that, Angela, picking up on what you've just said, I think that this is a curious moment in time where people speak about sustainability as well as durability. No, and on the other hand, as we talk about that, there are so many that don't understand glazing well enough to realize that you can actually interchange component parts to make something last another 5, 10, 20 years. So it becomes very, very easy for the untrained engineer or architect to say, oh, no, you have to replace that, and it's not repairable. When in fact, most glazing assemblies, and I'm going to say at least all the ones that I've worked on, except for maybe several anecdotal ones, the systems are designed with interchangeable parts. So it's become very clear that there's an educational component, which is what Angela and I think began with, which is to explain to people that locking mechanisms within a glazing assembly are hardware. That's not glazing. That's a mechanical component or an interchangeable component that when it wears out, because you use it 10,000 times or 20,000 times or 30,000 times, that you could take the locking mechanism out and replace it with a new locking mechanism that continues to perform, as opposed to this idea of, oh no, you have to remove and replace the entire assembly. This plug and play mentality. Listen, I want it now. Fix it. I don't want to go through a process of understanding. I think in the Italian culture, unlike perhaps the American culture, the recognition that things that are old are not obsolete, that you can, in fact, still maintain the historic quality of something, make it more beautiful by improving it and salvaging it. And I think that in glazing, because it's so misunderstood oftentimes, that people suddenly have a slapstick mentality to, oh no, that can't be salvaged, remove and replace. When in fact, most of these assemblies can be salvaged. It falls into the notion of the younger generation saying, wait a minute, this is not good for the planet that we just throw things away and keep putting things back in, and they only last 25, 30 years. And I've taken a very strong position, especially in the work that I've done in being able to prove through a standardization by looking at my 21 data points, 21 categories. Tell me about the sealant. Is the sealant met its life expectancy? Has it failed because of adhesion, cohesion, what you have? You replace the sealant with new sealant, it'll last another 30 years. Deformation, are the structural components damaged for any reason, right? The railings, the rails and the mullions, the jams, the intersecting connections, and those are components that you can actually look to and see if they are damaged. And a trained eye can tell you there's no damage. There's no frame joinery damage. The assemblies remain the same. A little bit of sealant could probably resolve any issues of water infiltration of any kind. Glass loses its effectiveness over time. Glass is interchangeable. And so I've established that there's a way of looking at something to determine what is the degree of injury, the magnitude of injury, and whether or not the injury can be connected to an event or just durability, serviceability, maintenance. No, and that's what I will be talking about at the conference. I think is look, there's a way of looking at this and justifying one way or the other. Should you remove everything, or can you determine from the injuries that instead of the patient being dead, that you could revive the patient, and that patient could live another 30, 40 years. Maybe it's just the patient's scraped up and unconscious, and you throw a little water on them, and water will actually have a positive effect. The patient will wake up. No, and I think that oftentimes you'll find people trying to have a pre-selected determination and work backwards to show that something is obsolete, when in reality that's not the case at all. If you follow the facts, and I think that's kind of what I'm going to be talking about, and it ties into all of the standards that Angela is working on.
I love that you mentioned the patient, because when we talk about people, we have a different approach. When we talk about a building envelope, somehow it's an object and we have no feelings. And I think there is a lot to be done also at an educational level to transmit the importance of also embrace elements that are aging throughout time, over time, because when we have a very important building stock coming from the Renaissance, etc., we do our best to maintain it, but somehow we can't control it fully, and we accept it to have some scratches and some defects that we don't accept on a relatively new building. So a material that is successful, in my opinion, is curtain steel. So curtain steel, we understand it's a highly performance material, and the rusty part, the rust, it does protect the material itself, and somehow we value it. We value also it from a design perspective, because we have a lot of objects that have been designed, made of this material. But other ones, we don't accept the aging of our building stock. And so this run for replacement instead of also an adequate, acceptance, even if I'm repeating myself, it's it's a change in our mentality, I think.
I think we and I'm kind of glad we're talking about things in we can create analogies to other areas. I was in Amsterdam, and they were restoring a Rembrandt painting. That was that the process was very deliberate and very and the piece was aged in it's 1800s, and you have this Rembrandt painting, and they're treating it as if as a priceless item, no. But then you look at how a envelope of a modern building that's made up of a curtain wall or a window wall, that doesn't have the same level or value to society, which I venture to disagree with that sort of hypothesis, or that notion that it's not the same. It is the same, because that some of these older buildings that the modern movement is only maybe 100 years old, right? And so some of these window walls and curtain walls and these technologies, when they disappear forever. I think out of that kind of concept, Angela, the way that Sachnowsky or Sack came into testing at construction research was that he was a professor at the University of Miami, and he was asked to create a test to determine air infiltration, if they could improve air infiltration through awning and louvered windows. Okay, and he actually invented the array to do the water testing back like in 1959, 1960, where as a result of inventing air and water infiltration testing, there are no longer awning windows. And awning windows, if you go around Florida or you don't see them anymore. It's like an antique, but people throw them away. They're all in the junkyards now. There are very few buildings here and there in the lower income neighborhoods where you'll see these old technologies. Well, that was a mainstay of the 1950s and 60s, when the air conditioner did not rule. And now people say, well, wait a minute, we're spending too much energy. It's not fair that parts of the world don't have energy, but everybody loves their air conditioning, But there was a time in the 60s and the 70s where there was no air conditioning in South Florida. And it was that technology that people would use. They would operate their houses and their buildings, and they'd use these things. People don't know what that is. The younger generation's never seen that technology, right? That was part of our history in South Florida, right? So I think there's a lot to be said about preserving where we come from, just like Europe and Italy preserves their history, and they do a really great job of it, quite frankly. Traveling to Vicenza and Venice and Rome and so forth, you could tell how painstakingly these things are kept, because younger generations have to learn from the older so that they don't repeat mistakes. No, you got to see what's been done. No, in South Florida, there are technologies now, the entire buildings that are being brought down that the preservationists are concerned about, how are we destroying our past. I recognize it, having, being involved in preservation. And there's also a recognition that there are technologies that you can improve upon. No, you can leave that language, that skin, that aesthetic that represents a certain time frame. So and that sort of fits in with this notion of reducing the carbon footprint, sustainability, resiliency. You can do it. It's just very easy just to say, listen, I don't want that. Just, throw it out. And so I think that we're kind of in the same plane. How can we protect future generations and still preserve sort of the past? Because some of our buildings are very special, and we should consider it that way. The curtain wall is a technology primarily invented in the States, for the high rise, right? And it's grown throughout the world. We were kind of the keepers of the first buildings, right? And of the curtain wall, right? And our firm is called that, Miami Curtain Wall Consultants, because it's in the food chain. The curtain wall is, in fact, the most sophisticated of the technologies. And we see more and more of that in Florida now. A window wall is, something very common, but the curtain wall is really taking its place lately in South Florida. So.
Angela, as we close this episode, I wanted to ask you, in terms of the conference coming up now in September, what do you think should be the biggest takeaways that your attendees should be walking away with?
So besides the technical content of the conference, I would say the networking opportunities and business that has been developed throughout the years at the conference would be the major takeaways for attendees. Otherwise, companies, they wouldn't come back to such a venue. And also the unique setups. So this year we'll be in an old church that is converted into an auditorium with sculptures, frescoes, so very unique locations. And since we have been talking about glass, and I'm very passionate about glass, and it's very linked to the Venetian tradition. So the grand finale networking event this year is going to be hosted at Wave Murano Glass. It's a furnace on Murano Island with glass blowers doing demos throughout the night. So again, it's going to be a lot of fun.
Excellent. Well, thank you so much, Angela, for joining us on this episode. Can you tell us where attendees could be able to register for the conference?
On the conference website, so it's www.performance-based-facade-design.org.
Excellent. All right, perfect. Angela, thank you again so much for joining us on this session.
Thank you.
We look forward to seeing you in Venice in September.
Thank you so much. It was a great pleasure.